in the US and how it potentially can be the key to reshoring. I was just on an earlier panel call today, and the president of CAMA, the Colorado Advanced Manufacturing Association, mentioned that it's really coming to a tipping point now where he feels that the difference between the winners and losers in U.S. manufacturing are going to be those who are able to adopt automation within the next 3 years, is the time frame he put on it. So I think it's quite a different story than we've been hearing lately, and certainly the steam is picking up. So welcome to our Wednesday night session, our fifth series. I want to say season. It feels like season. Our fifth episode of the IoT Recon series with our partners from ioterra. ioterra is a platform. They've created a very cool new technology to provide IoT product development quotes. So it's a tool that facilitates a very difficult process, and I'm sure Daniel can talk more about that, but they are going to have an event, a product development conference next Tuesday, starting at 8. There'll be lots of speakers, lots of talk about product development, very IoT focused, lots of exhibitors. So mark your calendars. And Katie, do you want to put the link in the chat here for that? And so you guys can check that out, and we'll send out a follow-up in the email as well. This panel will be recorded too, so if there are key takeaways that you missed or you want to come back and check out, you guys we'll send that out in an email early next week as well. And without further ado, I want to introduce Daniel Price, one of the co-founders of ioterra, and previously Breadware. With a successful exit as a product development company, really knows the space. And Daniel will be our moderator tonight. And I have the lucky job of signing off for a few minutes, and I'll come back here at the end where we will do a networking session. So we have kind of a cool way to do this where we split up into small groups so that you can actually get to know each other at the end. And we'll welcome our panelists to join us on that, but we'll do 1 or 2 or 3 potentially different few-minute segments where you can get to know each other, and we'll also give everybody the opportunity for a 30-second pitch to kind of get introduce what they're working on and get to know the community, because it's all about people and it's all about getting connected tonight. So without further ado, I'll hand it off to you, Daniel, and I will see you guys on the other side.
Wonderful. Thanks so much for the kind introduction, Greg. And yeah, as Greg said, I'm one of the co-founders of ioterra. We're a platform that's focused on product development, providing both solutions and services. In any case, I'll kick off with a couple introductory comments and observations about the topic of smart manufacturing and reshoring, and then I'll introduce our esteemed panel of experts here tonight. For me, this is going to be a pretty interesting and particularly fun topic, just in that it touches so many different hot buttons, you could say. I mean, we're going to hit on policy, we're going to hit on tech, we're going to hit on culture, we're going to hit on propaganda. So there's a lot that comes together as a confluence with reshoring and how smart manufacturing fits into it. As a quick level set before we kick off, there was a trade deficit for goods being brought into the US of $900 billion last year. So what does that mean? Trade deficit means that we imported about $1 trillion more of manufactured goods than we exported. And having a trade deficit is not intrinsically bad. It doesn't mean that we have a $1 trillion debt. It just means that we're importing more than we're exporting. And there's probably a number of reasons why the US wants to lower this figure. One is that a lower trade deficit, building more within our own shores, is going to allow for a more resilient supply chain, a quicker turnaround on supply chain. It also allows for better traceability into sustainable practices of the manufacturing chain. And the move to reshore in totality is going to minimize this deficit. And there's been quite a bit of reshoring activity in the last few years if you just look at the numbers. In 2020, there was something like 150,000 new manufacturing jobs created in the US. In 2021, that job is expected to be higher, maybe upwards of 200,000. And it looks like this trend is going to continue. Last year, something around 50% of US companies that do manufacturing said that they were investing in reshoring. This year, 80% of companies said that they're investing in reshoring. And so that means we're looking at hundreds and hundreds of thousands of new jobs potentially here in the US doing manufacturing, which is great, except we're also in the midst of a labor shortage, right? And it's a labor shortage that doesn't seem to have an end immediately in sight. So that hits our topic for today. Now here enters smart manufacturing technology, innovation in manufacturing processes, possibly to save the day. So the question that we'll be discussing with the panel is, are robotic arms here the answer? Are they going to resolve reshoring and labor shortages simultaneously? If so, what are the factors, the considerations, the complications that we all need to be thinking about? I have no idea. Luckily, we've got an esteemed group here of folks who might have more of an idea than me, in Ron from Juxtum, Michael from Universal Robotics, and Nikolaus from Optio. So I'll hand over to each of them to just do a quick introduction of themselves and their companies, maybe about 30 seconds each, guys, and then we'll jump into some of the panel discussion topics. So I'll hand it over to you first, Nikolaus.
Well, thanks so much for inviting me to the panel, and I'm pretty excited because I think the reshoring can only be a package deal between joint efforts with robots, digitization, and IoT Industry 4.0. I'm a robotics professor, and I did a lot of research into robotic autonomous manipulation and assembly, and I realized that manufacturers really need to digitize their workflow, and that's why we started Optio.
Fantastic. And to you next, Michael.
Yeah, so my name is Mike. I'm with Universal Robots. I'm a territory manager for the company. I've been with Universal Robots now for about 4 years, and previously had experience at Festo, which is a supplier of pneumatic components, electromechanical actuators. My background is entirely in automation. Universal Robots specializes in 6-axis collaborative robot arms. So I have some idea of how robots are being used to help in the reshoring topic, and I'm excited to discuss with the panel tonight.
All right, and over to you, Ron.
Thank you. Ron Pieper, I am with Juxtum. I've been in the machine tool metal cutting world for my entire career, over 30 years. Probably over 40 years now that I think about it. Work with machine tool builders, control manufacturers, machine tool distributors, quite a large variety of roles, including field service and technical support management. Last 10 years, I've been with Juxtum, which is a new brand name you might not recognize, but we've got significant experience in connecting controlling devices, CNCs and PLCs, in order to extract from them status and performance information, which we then offer up in a standard format. We use MT Connect, although we're growing into other formats as well, so that software companies that do the analysis, the collection, the storage, and presentation of that data have got a ready layer of connectivity. So my job is really to assess the equipment on the customer's floor and to work with them on what their needs are regarding connectivity, and then go ahead and deploy those solutions. So I've seen these systems from the beginning to the end.
Fantastic.
And I'm a big believer in it.
And we're going to touch on this later in the panel, but reshoring is affecting and touching different parts of the US in different ways. So with that in mind, gentlemen, where are each of you calling in from tonight?
I'm in Boulder, Colorado.
I live in Arizona, but for Universal Robots, I see the markets of Colorado, Utah, and New Mexico as well.
And I'm in Cincinnati, Ohio, the former and hopefully future machine tool capital of the United States.
Hoorah. All right, let's see. Let's kick off into some learnings about smart manufacturing, what it means and what it maybe does not mean. And so, Michael, I've got a question for you first, which is, when a lot of people think about robots and work, they have all sorts of things that pop up into their minds, and maybe some things that have been perpetuated by Hollywood, which may not quite be true. So I think to kick off the conversation today, let's define what is the real world and what is fiction. And if you could just talk about what some of the misconceptions are around robotics, and then maybe what specifically, what are some of the real culture and side effects that occur in companies when they do deploy robotics?
Yeah, that's a really good question. It's a good topic. Because as funny as it sounds, one of the things I hear really commonly is, we start talking robots, especially with, the people who've not ever worked with robots before, or have very little experience in automation. And I think instantly they think maybe like Terminator or Skynet. There's this idea that, or like that AI run amok or something. There's this idea that robots are smarter than us. And I think they're I think they can be incredibly accessible, intuitive tools to use. But at the end of the day, they're interacting with people, and people are programming these things. So as I guess as interesting as it might be to see Skynet, they're not. It's not what we're using the technology. It's not how the technology really is used in the manufacturing sense. Now there is a pretty big, there's a pretty big culture change I've seen, especially for customers who have never worked with technology like this in the past, and when they're adopting this for the first time. Great examples are manufacturing processes that have mainly manual labor, that all of a sudden you're injecting a robot into the middle of that. And especially with our technology, the universal robot is what's known as a collaborative robot, or a cobot. It's a buzzword that I'm sure most people have heard, cobots or anything like that. These are arms that are designed in many applications to be deployed safely next to people with no caging or guarding. And so there's a pretty large, I would say, paradigm shift that takes place when a cobot is deployed right next to human operators without safety around it, without like caging and guarding around it. Most people, when I got out of school, I went to school of mines in Golden, Colorado, and I worked for Frito-Lay in Denver when I got out of school. And we had a very large robot arm there that was behind caging and guarding. And the idea was, as long as that robot's running, you're not in the same space as it, because there's no inherent safety. If it bumps into you or something, it could kill you. All right. And so I think that same mentality maybe has been taken over to cobots as well. And I don't blame customers in the market for thinking that, but it is a huge paradigm shift. And it changes the way people think about robots. What I've told customers for years, especially after seeing more and more deployments of our technology, is that you need to, when deploying a cobot, you're thinking of the product more so as a tool, right, than as a separated space sort of replacement of a task. This becomes the cobot becomes a way to optimize human operators' performances, right? And so that's a cool thing, because all of a sudden, when you deploy this tech, people aren't thinking, hey, this is replacing my job. They're thinking that this is a tool that I'm getting in my hands that's going to allow me to do my job better. And there's a lot of things that go into doing that, right? I think what really makes Universal Robots so special, and I'm biased, of course, I'm a UR guy, but I think what makes UR so special is intuition and programming and ease of use, right? Because that's really palatable for people who've never touched robots before. I'm a chemical and biological engineer in my training, and to be able to pick up a teach pendant and have it be simple to read, easy to use, and I can track what's going on, that's really powerful. The maybe some of the intimidation factor of the technology goes way down when I get to see it. It's not behind caging and guarding, and it's on a pendant that makes sense to me. So I'll say the customers that have adopted this paradigm shift is that's the best terminology I can give, and that have really embraced what this technology is. They've seen huge success in deploying it.
Yeah, that's really interesting. The evolution from robot to cobot, from isolated encapsulated space to in the floor, working alongside the human operators.
It's such a big thing. It's such a massive transition, right? To put the humans back into production with the robot. It's the move from Industry 4.0, which is I think where we've existed for a few years, or a number of years now, into what's really exciting is Industry 5.0, right? It's this idea of optimizing robotic performance alongside optimizing human performance. There are things humans do great that robots can't do, and there are things robots are great at that humans shouldn't do.
Such as arm wrestling tournaments.
Right.
All right, so I think we're going to hit on robots a lot throughout the course of the talk this evening, because I know there's a lot of expertise on robotics here, but I also want to make sure that we touch on the broader category that is smart manufacturing, and at least put down a definition that we can build from. And so, Nicholas, maybe you can provide just an overview of, in addition to robotics, what are the set of factors that together comprise smart manufacturing, and how is it different than what we've done in the past?
So I think manufacturing really benefited very strongly from lean thinking, where you think about manufacturing as a value stream that leads to customer value, because the customer wants to buy something, has to be delivered in a certain time frame at a certain quantity, and that is what manufacturers understand to be the value stream. And when you put in a robot or an IoT device, then you actually would want to connect that to the value stream. So maybe your value stream requires your product not to overheat, not to be exposed to heat for too long. And so now when you understand that, you say, oh, I would love to buy a temperature sensor that would protect me from that, or would check on that. And at the same time, you might discover how all the steps that you do on your manufacturing floor lead to the desired customer value, and understand a robot deployment from that perspective. And I think what we shouldn't do is just deploy a robot and then compare, let's say, the cost of the robot with the cost of the worker that has been at that station. We should always look at how does this robot will affect the value stream. And I think we will see a lot more automation once people actually think about robots that way, rather than saying, oh, I don't want the robot anymore because the robot is actually very slow, or something like this. It doesn't matter how slow the robot is if you get more widgets out at the end, if the customer gets stuff in time, and so on. Yeah. So I think that is the paradigm shift that we need.
Well, there's the parable of the tortoise and the hare, right? And those robots, even if they're going slower, they can just go for 24/7 without breaks. You can put several in a line and they can all, just multiplicatively increase their output. I remember going into a factory once and all the lights were off, because this was a fully automated factory and it's just operating. The robots didn't have any particular need for lighting. It was somewhat eerie. And it's not exactly the cobot environment that Michael was talking about, but there's a paradigm shift in thinking required around what does efficient output capacity look like in these types of manufacturing settings. Mm-hmm. So, all right, so building off of what Nicholas said, I'm kind of painting the promised land on where an organization can be. Ron, I know you often are living in the thick of helping companies get over these major hurdles of implementing a bunch of legacy devices together along with new technology to actually have an effective digitization effort. What are some of these hurdles, and what does it sometimes look like in the trenches for these companies to get through it?
Well, the first thing that people think of when they look at these this big effort of digitalization is the benefits that they can get out of the data that they can see, the reports that they can acquire, and the tasks that they can go and engage in to cause a change. One hurdle, of course, is the fact that any system that provides insight to factory performance has an ROI of exactly zero unless somebody actually goes and does something. So the technical piece of getting the data is not quite as easy as everybody thinks it is. It is a sticky world full of headaches. It's the world in which I live. But the bigger hurdle a lot of times is getting the humans that are involved in the process, who have been doing their jobs in the factories for decades without this data, to have to open their minds to understand what the data is telling them. And often it's quite disappointing about performance. I've gone to a shop once. We walked through the shop to get to the other side of it, to where a conference room was. We sat down and talked to the customer about what they think their machine utilization is for any given shift. And they said, well, we're not very good. It's about 50%. And I said, well, you're probably about 22%, which is where most shops are. Several months later, we went back and reviewed performance, and they were oddly enough at 22%. But in that meeting, they also said, we're going to pull the system out. And the reason they had to pull the system out wasn't because it wasn't functioning. It wasn't because it didn't have the feature content. It was because it was rejected thoroughly by the people on the shop floor, because the message in deploying these kind of systems was poorly done. And operators just rejected it out of hand. They gave it the big brother spyware kind of tag. And it was a failure to understand the human element and dealing with this new data, and affecting the pride of the people who felt that it was a reason for them to be blamed for performance instead of as a resource for performance improvements.
That's fascinating. And so there's this evolution in mindset, and both thinking about performance, about the whole operation, and about the robotics themselves. That's required. And this makes me think of Nikolaus, because I know you're teaching robotics classes, Nick, at Boulder. So have there been open research initiatives, problems with robotics, and are these coming together to increase adaptation, or at least the way that people are thinking about how robotics can be applied to new situations?
I don't really think it's a research problem. We have seen some new things like bin picking becoming more and more a commodity, and now you can easily buy it for, let's say, universal robots. And now the question would be, okay, what is the next technology that we would need that would unlock something? And I'm not sure there's anything to unlock, but really the personnel issue that Ron mentioned. I think we need a fourth panelist who is an educator. I mean, also an educator, but who actually educates the workforce at the same time on how to use value stream mapping, on how to use cobots, on how to use data, how to think about this holistically. And we try that with our company. We have a lot of content marketing, and so does UR, and probably you too, Ron. But I feel we can't do it alone, because there's so many carrots held up in front of the manufacturers and customers that they don't necessarily, engage in somebody's, mantras and evangelization, because they heard it so many times. I have the solution, I can do it.
Nikolaus, does that role, this factory floor industry educator, exist? Or is that a role that it would be nice to have, but it hasn't really reached its maturity yet?
So there's an industry around lean and people who teach that. And so when I started learning this, we paid a lean consultant too, and we wanted to give him to the customer for free. And we said, hey, can you indulge this guy? He's going to help you. And he said, I don't have time for this. I don't have 2 hours for that guy. I'm sorry. No, thank you. And so they don't want to do that. It's difficult. It almost seems that maybe all the companies who are offering something along these lines should come together and work together on these kind of materials and link them. If there's an alignment around, let's say, lean and value stream mapping, and get the lean consultants on board and help disseminate these things, and then help sell the robots, help sell the IoT devices. And then the customers would also know that they actually get helped, instead of just wasting money again and again, which they have been doing often in the last decades on certain hot topics.
So it seems like this recurring theme I've been hearing is patterns of thought and roles and adaptation in the way in which a factory or a manufacturing floor is being organized, which makes me think about jobs. And in the research that I had done, these hundreds of thousands of jobs that I was talking about earlier that are coming to the US for manufacturing, these are actually high-tech jobs. These are not folks on the factory floor, moving widgets around on a conveyor belt.
Right.
And so I'm curious, actually open question to all the panels, what are new careers or new jobs that have hit the market now because of some of these robotics or because of some of these smart manufacturing processes?
I'd like to address a part of that, and taking what your comment is and going back a little bit, we have to understand that automation is a category of moving material, moving things, and robots are just one tool in the automation world. They're really nothing new. They're a computer-controlled set of mechatronics, and they do a task. Because it's called a robot, it has a certain stigma about taking jobs. They don't take jobs. Robots add jobs. They do it very clearly. You have to look no farther than South Korea, who does a phenomenal amount of productivity in a land chunk the size of Illinois. The jobs change. The technical level has to increase. There's obviously people who build and program the robots, but the jobs come from increased productivity. And increased productivity really needs a lot more back office workers to handle all the various stuff that goes in that is not particularly value add productivity related. So companies expand when productivity goes up. The jobs do change personality though.
I totally agree, and can validate it with what I've seen, right? From deploying hundreds of robots across this four corners territory. What Ron's saying is exactly right. In most cases, productivity is dramatically increased with the addition of technology, right? With the addition of robotic arms, or, I mean, robot's a giant word, right? Robots, as in my definition, include things like, AMRs and AGVs as another technology to move things around, right? And those are a similar but different skill set. I would say maybe than in like a 6-axis. But certainly one of the jobs I've seen that more and more customers are becoming interested in are people who understand how to find good applications and then take a technology that's fairly simple or straightforward and deploy it, right? So as it relates to our product, the Universal Robot, customers, I feel like, are either looking for or repurposing people internally to become sort of like this automation specialist. They're responsible for identifying throughout the plant, maybe I have a robot that's doing CNC machine tending, but I also recognize how it could do welding, or I recognize how it could do deburring, or, some, X task. And this person now is responsible not only for the deployment to where, let's say deburring, right? They're also responsible for setting that cell up and getting that and making it an automation cell, right? And so what's so cool about that, one of the pieces of my job that I love is you get to upskill these people internally, right? You're teaching them about a new technology. They're looking at a problem differently.
Yeah.
Right? It's a cool thing.
I want to add to that by saying that the advancement in technology and software in particular is changing the way a robot is deployed in an application. Formerly, robots were used in a very repetitive environment. Okay, you sit it down, you program it, and it does what it does all day long. However, technology is starting to allow robots to be deployed in a much more variable environment, like a job shop, where different lot sizes and part numbers and materials are going to be coming through the shop. And the concept of taking a robot and plopping it in front of a machine tool, let's just talk about machine tending, and having it do a task at that machine for a fairly short run job is starting to become quite a reality, instead of having a major integration effort, because normally you've got one robot and one machine and you've got to do work to make them talk to each other in the correct way, a lot of wiring, some lateral logic changes and so forth. And that is starting to go down with the idea that robots can be much more easily programmed to a short run task than in the past. And that's going to really blow up the use of this kind of automation, which really can help mitigate the problems we've got in our labor market right now.
Can I ask Mike something about the robots deployment, Daniel?
Please go ahead.
Did you feel that when you deploy the robots that the customers actually start to think more about their process and then actually improve the entire process around it? And so the benefits come from both this additional thinking and the robot itself?
Yes. To what degree? It's sometimes difficult to say. So like one of the things that I think is interesting, right? I think where Optio is one of the next logical iterations of technology that's intuitive, right? Because then you start to look, so like, I'll give you an example. Let's say machine tending is the example, right? If the customer is thinking about deploying a collaborative robot into a CNC machine tending job, they have to think about a couple of things that normally they wouldn't with a person, because a person just inherently understands it, right? Great examples are, how do I feed raw parts to the robot and how do I get finished parts out of the robot, right? So it's a process flow chain. They're looking at how the process around the machine is going to change because of the addition of a highly repeatable, always running device. So I would say some customers, all customers that are deploying robots to a task like that, they're at least looking at the task, right? They're at least trying to understand how the addition of an arm is going to change what the flow around that task looks like. I would say there are a group of customers who look beyond just that task. They look at the line, right? And then there are some customers who look at the plant and they say, okay, how would the addition of multiple arms here completely overhaul my line? And I've got customers that are doing this, that say, I'm not going to just look at application X. I'm going to see how the impact of arms, or AGVs, or whatever technology along the line will adjust how I'm going to do business, or how I'm going to produce X part. And that's why I think Optio is interesting, because I think when that clicks for more customers and they start to realize, I've got my bottleneck in a place maybe I don't think it is, that's when I think they'll start to unlock some of the potential of their line as well. It's exciting. It's an exciting time.
Thanks.
So, and feel free for anyone in the audience to throw questions in the chat or the Q&A, and we'll address them here. But I've got a question, maybe initially targeted for Mike and Ron, but Nick, I'd be interested in your thoughts too. So I mentioned earlier that there's been regional variations in smart manufacturing in the US. In fact, over the last 2 years, the biggest beneficiaries of US reshoring activity have been 3 states. It's Arizona, which Mike should know well. It's Ohio, which Ron should know well. It's also Tennessee. Do you guys have a feel for why we're seeing the asymmetry and where smart manufacturing and automation is happening?
In my world, the people who take up the data collection piece and storing the histories of performance and looking at ways to improve it has largely been in the aerospace industry. These type of efforts are usually with high value and or high volume parts, and the aerospace industry, between engines and airframers, have got a plethora of both. The automobile manufacturers, of course, have got a whole lot of high volume. They traditionally have done a lot of the data collection on their own with homebrewed solutions and have not relied upon outside suppliers. So there hasn't truly been a market for companies to go in and do things, although that is changing. So we are seeing automotive pickup, we're seeing off-road and heavy industry pickup as well, not to mention the very fertile world of medical devices and firearms. So these are areas where we are starting to grow quickly in those 2 verticals.
And as for my region, so Ron, as I was listening to you, I think you said 4 different segments or industry segments. And of those 4, 3 are the same in Arizona, right? The only one I would say we don't have a huge presence of is automotive, right, in the Arizona market. But I can speak to aerospace is really a large market here, and that it's from the very, very large guys, you know, like the Honeywells, Boeings, Raytheons of the world, all the way down to, you know, the shops where they're sending their work out to, right? I would count all of that as the aerospace world.
Absolutely.
Medical device plays a really big role in Arizona. And then I'm spacing on the last industry you mentioned.
Firearms.
Firearms. I was gonna say, yeah. So yeah, firearms is obviously big here as well.
Yeah, a lot of that's in the Northeast. So
yeah, yep. So yeah, I would say those I've seen. I think one of the things that's interesting is across those 3 industry segments, I've seen a massive initiative from some big, you know, big and small customers towards understanding new technologies, and not just understanding, but picking them up and deploying them, right? So, you know, a couple of applications and customers that come to mind, that an initiative was created to say, okay, look, cobots are a sort of a new innovative way to think about using a robot arm. We're going to get some ones for R&D, or we're going to get some that we're going to deploy to applications, and we're going to let our team figure these things out, right? Because we have to, because if we don't, we know we're behind, right? And I'm seeing more customers adopting that mentality as well. You know, like as cobots become more prevalent, Universal Robots has sold over 50,000 cobots globally, and the number grows like crazy every day. I think customers have this sense now of, I know my competition is doing this, right? I know that this is out there. And if I'm not at least thinking about it, right? And even now, I've been in the role for 4 years. I'd say if you're still in the realm of just thinking about it, you're on the lagging side. Because
it goes beyond robots. It really does go into simply understanding at a deeper level what's going on and where can I justify the use of automation, which really requires, if you want to do it right, you've got to understand where your gaps are and where you can improve. And simply looking at machine utilization is the very best place to start. You'll find a huge gain just based on visibility and performance on some really mundane stuff when it comes down to why am I not producing what I should? Why are my machines not running when they should?
Yeah.
When you solve those, you've probably got a 20% productivity improvement, and now you can very objectively justify the use of the investment of a robot to help identify gaps after you've made a first layer improvement across the plant floor with disciplined work.
Well, I fortunately, or whatever, don't have to do a ton of work with selling any of the autonomous mobile robots. But MIR, Mobile Industrial Robots, is a sister company to Universal Robots. They're both owned by our parent Teradyne. And so I get to see lots of MIR applications and MIR deployments. And I'm always surprised that one of the areas that could use lots of improvement across virtually everybody I talk to is just the movement of parts and materials around there's so much cost associated every time someone's touching something and moving it from A to B.
Yep.
You know, and you can eliminate, or I guess you could gain a lot of productivity if you can handle more things in one pass.
And it's not just the physical moving of the parts, it's knowing where the heck they are. So some of the technologies that are starting to come to the fore right now are high accuracy indoor positioning and things of this nature, where we can start tracking, where is this pallet of parts? Where's this fixture that I need for my next job coming up? And simply knowing where it's at, it allows you to do the augmentation of a value stream map, a spaghetti diagram, a whole lot easier, because it is objective, it is real, it is proven.
Yeah.
And from there, you get into the lean principles that were mentioned before by Nikolaus, and we can start looking at better plant layouts, work piece flow, human flow, et cetera.
Yeah.
Let's follow that thread a little bit farther, Ron. So I know that in Juxtam, you're helping companies hook up their CNCs, their legacy equipment, their robotics, their lines. Then they're getting all this real-time machine data. You know, if we look down the road a little bit, what else are companies going to be able to do once they have all this real-time data living in their floor?
Well, it's a bit disappointing because when I go to trade shows and look at people who call me, and some of my customers are software companies, many of them are, and so many of them are doing the same thing. And there is still a very valid market for just taking the data that they get from the machines, storing it and displaying it and identifying downtime reasons and things of this. And if you're not doing that, you're kind of behind. In fact, one of my favorite sayings when I do talks and webinars is it's not too late to be ahead of your time. So you best be on that train at least. Now you've got this facet of data from the equipment itself. And what disappoints me is the fact that there's not more being done with it on a large scale commercial basis. For example, if we look at the idea of repetitive machining, am I capturing the profile of the execution of a work piece? And if you look at a part program, it's nothing more than a list of Simon Says instructions of what the machine itself is going to go do. But can I collect the data in a high-speed fashion? And we're getting to the point where we can, loads and vibrations and things of this nature. And from that, can I assess the degradation of my process as it's being executed, and also my machine performance, my machine health? Are my tools wearing? Is my coolant getting diluted? Do I have a intermittent issue? Do I have a such as a servo encoder cable that's starting to go bad? Do I have a chipped insert? And how can the data show that prior to me making a scrapped part? So this is a big part. And if you look at vibrations, and I'm executing this program, and I notice that at a certain point in the program, I get a vibration. How can I mitigate that? Well, simple mechanical dynamics say that I can probably change my cutting processes, and we can start closing the loop and changing the feed rates and speeds at that particular point in the program. And that's just the productivity piece. But we look broader than that. Dynamic scheduling. If I know that a machine's going down or not producing to plan, how can I start routing work around that machine to more productive machines? How can I idealize a particular work piece category against the proper machines? How can I best cost what it takes for me to make a part? And how can I evaluate incoming work to know whether I'm going to be able to be competitive when I quote it and be accurate when I quote it? Because oftentimes the people who quote the work are totally different than the people who actually have to go execute it. So there's a huge number of facets, MES integration, et cetera. And not to mention that if you're out there selling machining services and you've got a plant that really has a great handle on what they're doing, you can tell the customer that it's going to be quoted accurately, it's going to be delivered on time, it's going to be made to the quality that they expect, because you know already how good you could be. So outside of just justifying corrective actions here and there with humans, there's so much more that can be done with this data, and we're on the cusp of having that. I just want to get there faster.
So circling back to the theme of the night, which is smart manufacturing and reshoring. And this will just be an open question to the panel, but with the culture, or the prevailing culture right now that has an interest in creating US jobs and doing US reshoring, with the government incentives that are also in place for companies to do that, how has that played into sales or pilot strategies that you guys using? Has it played into the strategies at all?
I can talk a little bit on this. I'm a salesman, so I can talk a little bit on the sales side, on technology. I mean, I'd say certainly, incentives to automate, incentives to invest in capital, incentives to, upskill, so that training, bringing on resources that understand technology, anything like that is going to, have a big effect. I guess for customers who are willing to adapt, right, to the new technology, because there's plenty who aren't. One of the coolest things about I've always thought, since I got into technology years ago, it doesn't increase at a linear rate, it increases exponentially. So if you can keep up with the curve, you can start to get into some really cool things. And it allows, I've got, a couple great examples of customers who, I mean, it's a two-man shop with 2 CNC machines that have adopted a robot arm, right? In the past, that's a pretty much unheard of idea. The technology wasn't there. The barrier to entry on the programming side was monumental for a shop like that. But all of a sudden now you've got a piece of tech that is very easy to use. It doesn't require the guarding and caging in most applications. And it's flexible. It's just like Ron mentioned, the flexibility in being able to say, okay, I'm going to deploy here, for machining, and then I'm going to go redeploy somewhere else. I think customers that have done even just a little bit of homework, they've watched case studies, they've seen one of these things in action. They're the ones who are, and that now are adopting it, I guess. They're the ones who are seeing the biggest returns, the biggest benefits by getting into it.
I would advise any company that's looking to get into this to find their local manufacturing extension partner, because the government is very actively funding efforts to do digitalization through the use of assessments and deploying technologies, and it can often be subsidized to the point where it's affordable. And as I know firsthand, the improvements in productivity are very real, and we need that.
Well, I mean, you hit on something else too, Ron, that we haven't talked about, and that's the cost of some of these things. Was, I guess, in the past beyond the reach of most, really small job, like a small job shop or something. But now, I mean, you can get a cobot for between 30 and 50 grand, right? That's a big game changer.
And how quick can you set one up if you have brought a robot to an existing machine? I don't mean to give you a sales pitch opportunity here, but robots aren't my.
That's a good question.
What's it take to say, well, I got a run of 20,000 parts on this lathe, and how can I automate that with a cobot? What's it take?
I would say, so I can speak to what I've seen, what I've done in my region, as short as hours, and as long as weeks, depending on how complex, right? I mean, I think every customer decides for themselves. I've got a good example. I've got one customer that's doing machining, and then the part comes out of the machine, it stays in the robot's hands, and it goes directly to deburring, like on a stationary wheel, right? And so setting both applications up originally, which is what this customer opted to do, it required more, so it took longer to do it. But I have some customers that all we're doing is, I'm tending a bar fed lathe, and you can get something like that set up really fast. I mean, hours is not an exaggeration. The robot itself is really flexible. It's lightweight. Even our heaviest models go only up to about 60 pounds. They plug into the wall, right? There's 110 AC. So they run on wall outlet power, which makes them really nice and easy as well. And then there's all sorts of tools that are plug and play with the universal robot. So you don't have to worry about learning a bunch of different like interfaces or coding or anything like that. There are some really nice tools you can just plug into like in the realm of grippers, or sort of in like what you do, like interfacing to, for example, interfacing to CNC machines. There are plenty of tools that make it plug and play. And so you're not figuring out like scripting, or you're not figuring out multiple interfaces. You're just looking at start cut, stop cut, open door, close door, open chuck, close chuck, kind of those kinds of controls. And that's, I would say, easy enough for just about anybody to pick up. So, I mean, really, you can get these things deployed very, very quickly if you want.
Michael, you're attracting some interest. There's some questions from the audience for you as well. So it's a two-part question, but question is, are you seeing applications for UR robotics in industries outside manufacturing?
Oh
And
yeah.
if so, like how is the ROI analyzed for deciding whether or not to integrate a cobot?
That is the question, right? That's the one I always, not always, but that's the one I frequently get was talk ROI. As far as outside manufacturing, manufacturing is obviously a huge word. I would encompass any kind of, most of my applications, I'd say, are in some sort of manufacturing process. But I've got plenty that are in what I might call retail, right? Things like, for example, out in the California area, we've got robots that are making smoothies. I've got a robotic barista in Golden, Colorado. Applications where the robot is part of advertising. I've got a couple of unique applications where the robot is deployed into environments you wouldn't think a robot would go into, right? Like outside in a dairy barn, in like textiles. Sewing would be traditionally a really difficult application for one robot arm, but these cobots are easy to work with. And it's been a fun job to be at UR because I've gotten to see how people take a pretty simple to use piece of tech and apply it to applications. And so there's a huge range of applications that we're getting into. So I guess there are applications outside manufacturing, I would say in the traditional sense. By far and large, machine tending is my most popular application. I'd say probably globally, that's the case with UR. Machine tending is a huge word though. That can mean CNC, that could mean injection molder, that could mean presses, any sort of thing where I'm taking like a part, putting it into a machine and then pulling a finished or done part out, I would categorize as machine tending.
Okay, fantastic, thank you. Those are some interesting and unique applications.
Yeah.
So, all right. Enough of you, Michael, for the moment. I'm curious about the company names that we have represented here, except for Universal Robotics, because your guys' name is somewhat self-explanatory. But Nikolaus, why the name Optio? What does it represent? And then Ron, why the name Juxtum, and what does that represent?
Well, Optio is there's a centurion in the Roman army which has 100 people, and underneath is the Optio who manages a smaller group. But also Optio we liked a lot because it's short and it is getting you to optimal, the true north that the manufacturers seek. So that's kind of the story behind that name.
Well, fascinating. So the Optio in the Roman legion is the admin that's operating underneath the centurion and making sure everything runs smoothly and efficiently.
Yeah, about like 10 people, 12 people, something like that, I think.
Oh, fascinating. That's slick. All right, are you also a Roman legionnaire, Ron?
I'm not. But I have been called a Renaissance man, and that's only because I do everything myself. Juxtum was a marketing created word. It came from our CEO. It is a bit of a contraction and a spin on a few Latin words, and I would be doing everybody a disservice if I even tried to explain from where it came. I do know that there is some meaning behind it, but I got customers to talk to, so I don't worry about that stuff too much.
Not a worry. I thought it's a unique mashup. So I thought there could be something hidden in the banister there. So I see
guess,
Greg's,
but that would be just pulling something out of the sky. So
I see Greg's joining back in, so it probably means it's time for us to wrap up. Greg, do we have time for any closing thoughts on the subject?
Absolutely. Yeah.
Okay. Well, yeah. So we hit on a lot. We spent time on what are the new roles that are being created with this reshoring initiative. We spent a lot of time on what the smart manufacturing floor means, how robotics and cobots fit into it. and then where the future is sitting, as these companies, Optio, Jexam, and Universal Robotics, really bring factories and warehouses and manufacturers to the next level. So for the panel, 30 seconds, any closing thoughts on reshoring and smart manufacturing, what we should all watch out for?
I think it has to come down to looking within and never making assumptions that you are better than you think you are, because we don't have the luxury of massive amounts of cheap labor. We don't have the luxury of people dying to enter this industry. So we are going to have to make the most of what we have. My analogy has been my brother-in-law, who is doing pretty well, and every 4 or 5 years he'll go out and spend many $1,000s on new golf clubs, thinking that he's going to improve his game, and all he does is get lost better. And I'm not a good golfer, so I don't have the right to tell him this, but I think you should go out and learn how to use your equipment in the very best way that you can. And when you become better at the process of what you're engaging in than your equipment is, then you can justify adding new equipment. So learn how bad you are down to the nth degree, and then you know exactly what your path forward to improve is. But don't think that by throwing new equipment at the problem, you're going to solve the world's problems. Robots, for example, are fantastic when they're applied in the right situation and in the right role. So shed the ego, look within, be critical of your own operations, and work to improve before you start spending money on equipment.
I think to go with it, there's never been a better time to automate. In my opinion, there's never been a better time to get into. So the barriers to entry on the programming side, on the cost side, what these new pieces of tech, not just in cobots, in many fields, are capable of doing, is incredible, right? And then the idea that I could put someone in front of this and within minutes have them programming and doing something useful is incredible. So I'd say also take advantage of, there's never been a better time to get into it. The technology's never been quite as user-friendly as it is now.
I agree.
Now, I can add to that. We have seen in the last 3 years that now things can be delivered to your doorstep within an hour of ordering something. And there's a tremendous gap to where that stuff comes from and how long it takes to make these things and ship them over from China or elsewhere in the world. And I think we will see a lot of pressure to make things much more efficiently and faster here in the US to build up on that, now that there's no more juice in getting it to consumers faster than that. And so I think we should be ready in serving manufacturers these things and help them to get there. And I'm very much looking forward to that.
Great.
Well, I want to say thank you for a great conversation, you guys. Give a round of applause here to our panelists. And Daniel, amazing job as a moderator. It's really, really great to have you as always. Thanks for pulling it all together, doing all that research, making it a fun conversation. And yeah, I want to remind everyone, so next Tuesday we have product development conference, and we'll post the link up here again if you're interested in that. And we're gonna break out now into a different room. We can't do networking in this webinar setup, so we're going to post a link in the chat to that room. There it is. And how we'll do that is we'll all cruise over there, and on my mark, we'll give it a couple more minutes. And then we'll give everybody a chance, 30 seconds to introduce themselves, and then to break out into smaller groups to have more meaningful discussions. And I do want to also mention, sorry, I didn't mention this earlier, but Garrett sends his apologies. He wasn't able to make it tonight. He had a family emergency, so kind of came on last minute. And I know probably there are some folks here that were interested in hearing from him, but I'm sure we'll have him back as a close partner. And Internet hacks. And without further ado, thank you all. And if you want to join us for a few minutes of networking, you can click over to that Zoom link, and I'll see you there. Let's go. See you on the other side.
Thank you, Greg. Thank you, Nick, Michael, and Ron. This is quite fun.
Good stuff.
Yeah, thanks for having us.
That's a fixed audience. You have to switch the meeting.
Yeah. Oops.